Hello, in this lesson we are looking at sequences and patterns. Our requirements are to write arithmetic and geometric sequences recursively and with an explicit formula. We're going to use them also to model situations and translate between the two forms. Also, we're going to look into just sequences and the fact that they are functions. The subset is the domain of integers, and we're going to look at all that a little bit later. But in this lesson, we're going to focus primarily on arithmetic and geometric sequences and how to deal with them recursively. Okay, so we'll deal with explicit formulas in the next lesson. All right, so here we go. Just real quick, a sequence is like for our purposes, it's like a list of numbers. So 1, 2, 3, 4, 5, 6. That's a list of numbers. It's a sequence. 2, 4, 6, and so on. That's a sequence. 1, 3, 7, 13. That's a sequence. Now, sometimes sequences are finite, which means that they have an end. This one's finite. This one's finite. They end, they stop, and others have, they're infinite. Okay? A series is, okay, so that said, there's also one other topic here that we may kind of get to in a future lesson. It's not our primary goal right now, but a series is the sum of a sequence. So if I was to add up all of these things here, 1 plus 2 plus 3 plus 4 plus 5 plus 6, that's known as a series. It's when you add all the terms in a sequence. We'll worry about that later. So rolling on to the next slide here. There are two special types of sequences. These are not the only types of sequences, but there's two special ones that every good math student needs to know. There's the arithmetic sequences, and there's the geometric sequences. Okay? The key defining characteristic between an arithmetic sequence and a geometric sequence is adding the same number in between the terms, or multiplying the same number in between the terms. Okay? So just to kind of point that value out, if you're adding the same number each time, it is called the common difference that's in between the values. So if you were to go 1, 2, 3, 4, 5, 6, if that's your sequence, then you're adding 1 each time. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, and so forth. Adding 1 every time, that's the common difference. Now, if you had a sequence such as this, 1, 2, 4, 8, 16, 32, we're not adding the same number each time, but instead we are multiplying the same number each time. That number that we were multiplying there was 2. So we were 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and so forth. That's called the common ratio. So, the two special types of sequences are arithmetic sequences and geometric sequences. Now, I'll go ahead and tell you this. This right here is not the word arithmetic, although it's spelt the same way. You learned arithmetic maybe when you were in kindergarten, first grade, and that's a noun. You know, it's something that you do, arithmetic. And here, as an Algebra 2 student, we're dealing with arithmetic sequences. So there's arithmetic and there's arithmetic. Now that's an adjective, and it's describing the type of sequence that we're working with. They are related both, in the case, to the word adding. So we'll get back to that later on, but so let's look at an example here. So I'm giving you an arithmetic sequence right here. Arithmetic sequence. 2 something 8. All right? So what goes in between those two numbers if it's an arithmetic sequence? Everybody think about it. Okay, I've got one suggestion of being 4. Is it 4? Okay, what do you think? 5. Maybe it's 5. What do you think? 5. 6. Okay, let's find out. It's an arithmetic sequence. Here's what you do. If it's arithmetic, then you're going to be adding the same amount like, let me try that again. You're going to add something to get this value. And whatever that thing is that you add, you're going to add it again to get this. Now, I have a trick for doing that. My trick is to take, what is 8 minus 2? That's 6, right? And so I'm going to add something here and then something here, and the total jump that I've made is 6. So what I do is I take that 6 and I divide it by 2, and I get what? 3. So this is going to be the amount that I'm jumping. All right? So 2 plus 3 is, and 5 plus 3 is, okay, so it works out. Does that make sense? Okay, we're going to see lots more examples of this, so if that kind of throws you a little bit, it's not the only time you're going to see this. It's going to be over and over again, all day long, or all lesson long here. Okay, let's try this again. Now, I'm going to give you a geometric sequence, in this case, geometric. And so the rule for a geometric sequence is that you multiply by the same number each time you make a hop. Okay, so we're going to go 2 times something, gives me whatever goes in that blank there, and then that times that something again gives me the 8. So, do I have any guesses before we get started here? Yes? 4? Okay, you think you multiply by 2? Okay. Anybody else? Okay, so here's my trick. Now that I'm dealing with a geometric sequence, I just take this 8 and I divide it by 2, and I get 4. Now I can cut. So I can cut that in half, dividing by 2 again, and I get 2. And so what this right here tells me, that's my jump value. So I'm multiplying by 2 here, multiplying by 2 here. So what's 2 times 2? 4. And what's 4 times 2? 8. Okay? So that's my little trick in this case. Now you're going to see more examples of this, and it'll make more sense to you very shortly. So I don't really care about whatever this says. Forget it. So let's move on. Now here's some abbreviations. When we're dealing with sequences, like let's take the sequence 2, 4, 6, 8, 10, 12. All right. This right here is the first term. It's A subscript 1. Okay? That's the first term. And the second term would be A subscript 2 is 4. That's the second term. Okay? Anyway, so the nth term is just some term way off in the distance. I'm not sure which one it is. It's going to depend on the problem. All right. So now we're going to talk about. By the way, this A subscript 1 is used for. It's the first term for arithmetic sequences. But I typically use G subscript 1 to mean the first term of, not the arithmetic, but the, what other type of sequence? Geometric, yes. Okay, so that's my little note here. Now also, you're going to see this little thing right here, R, okay? That's really important. It's the common ratio. And I want you to bubble in that formula. It is super important. We're going to use it over and over and over again today. Also, we're going to talk about the common difference for arithmetic sequences. And I want you to bubble in this formula, D equals A subscript 2 minus A subscript 1. By the way, technically, I would think of this as being a G subscript 2 divided by a G subscript 1. That's for geometric sequences, and this down here is for arithmetic sequences. Okay? So, now, our goal here is to do a couple example problems. So we're going to find the first term in either R or D, depending on which type of sequence it is. Now, obviously the first term would be A subscript 1 if it's an arithmetic sequence. It's going to be G subscript 1 if it's a geometric sequence. Alright, so let's look at this very first example here. You have 1, 2, 4, 8. The very first term is a 1. Okay, it's right here, the very first term. That's easy. Okay, now the real trick is, what do I do to get the next term? What would be the next thing following this 8 here? So we're multiplying by 2, right? So we get 16. So the common ratio is 2. That's what we're multiplying by. So write down R equals 2. And by the way, what is the first? Now, if we're multiplying, that makes this a geometric sequence. So what is the first term? The G subscript 1. What is it? The very first number listed here is a 1. Okay, so there it is. R equals 2. G subscript 1 is 1. Now, next example. 1, 2, 3, 4. What's the next term? The next term is what, 5? That's what would come next. How do we get that? By adding 1. So you can tell the pattern here is adding 1s, yes? So this is not multiplying by 1, it's adding 1. So now we don't have a common ratio, we have a common difference, and that difference is 1. That's what we're adding each time. Now, the first term here, this is an arithmetic sequence, so the A subscript 1 is what? 1. Got that? Okay. Third example, 2, 6, 18. What do I do to get the next term? So what do I do to get the next term? Multiply by 3. So I'm multiplying by 3, and I get R equals 3. Okay? So what is the first? Now, if I'm multiplying, what is the very first term? G subscript 1, and that is the value 2. Next, 2, 5, 8, and 11. What do I do to get the next term? I'm adding here, yeah? I'm adding 3, so that makes the common difference be 3, and the A subscript 1 is what? 2. Okay? Now, at this point, what I want to do is take a moment with the class, and I want you to practice. I want you to practice this with these 3 terms, or these 3 examples right here. Okay? So let's take a moment. If you're watching the video, you should probably pause it right now and see if you can figure out what the first term is in each of these cases, and also the common difference or the common ratio depending on the sequence. So I'm going to pause the video right now, give it a shot, and we'll return when we're ready to check our answers. Okay, we're back. We're back, and we have looked at these 3 problems here on our own. We're going to check them all together right now. So here it is. A couple things that we had to deal with was, once again, R is the common ratio, and it's used for the geometric sequence. D is the common difference, and it's used for the arithmetic sequence. Or, yeah, the arithmetic sequence. Okay? You need those formulas, and we're going to use those here. So, get ready. 2, 1, 0, negative 1. What you can see is you're constantly not multiplying, but not really adding either. Instead, it's actually subtracting. We're subtracting 1. So here's how this works. Right up here, the formula says take the second term and subtract the first term. Second term, subtract the first term. So I could do like this. I'd be like 1 minus 2. And what does that equal to? 1 minus 2. negative 1, right?
Yeah.
1 minus 2 is negative 1. How about 0 minus 1? What is that? Negative 1. What about negative 1 minus 0? It's negative 1. So what does that tell us that the common difference is going to be? Negative 1. Now what is the very first term that's listed here?
2.
So A subscript 1 is 2. That's the first example. Now let's look at this next one. What is going on here? What's 1 minus 2? Negative 1, right? And what is 1/2 minus 1? 1/2 minus 1 is a negative 1/2. Look, are we adding or subtracting the same number here in this second term? Is it adding?
No.
No, it looks like it's probably going to be multiplying. So this is not an arithmetic sequence. It is hopefully, it's a geometric sequence. We're going to make sure of that right now. So here's what you do. If you think that it's geometric, then you're going to use this formula right here, and you're going to divide the second number by the first number. So the second number is a 1. I'm going to be like 1 divided by 2, and what do I get?
0.5.
I get 0.5 if you're doing decimals. What about 1/2 divided by 1? What is that? 0.5. You could also do 1/4 divided by 1/2. Now, I just want to encourage you, if you're on one of those old school TI-83 calculators, or for that matter, just a regular 4-function calculator, 1/4 divided by 1/2. If you try to type in this 1/4 divided by 1/2 into your calculator, if you try to do that in an old calculator, you're going to get the wrong answer. That's because you're dividing fractions. I'm not going to get into the reason why. I'm just going to tell you that if you're dealing with fractions in your calculators, it's often a safe bet, the best bet, to go ahead and put parentheses around each fraction. So 1/4 divided by 1/2, the bottom line is, it is 0.5. Okay, so all of this proves to us that the common ratio is R equals what? 0.5 or 1/2. However you want to say it. I'll go with 0.5. I'm cool with that. And then the very first term is, it's a G subscript 1 is 2. The common ratio was 0.5. The first term was 2. Now a lot of people here on this problem, they realized the pattern was to divide by 2, right? Divided by 2. And a lot of people wanted to put down R equals divide by 2, or something that doesn't exactly make sense. Here's the thing. Dividing by 2 is correct, but I don't want what you divide by. I want to know what do you multiply by. So, dividing by 2 is the same as multiplying by the reciprocal of 2. The reciprocal of 2 is 1/2. So dividing by 1/2. So R is 1/2. Now, if you still have trouble with that whole dividing by 2 is the same as 1/2, I would just encourage you to go back to like 4th grade, or you could probably get some YouTube videos somewhere that deal with the topic of dividing by a fraction. So, if you struggle with this, look up, Google it, YouTube it, how to divide by a fraction. All right? That's for another lesson. Here, let's go ahead and do this third problem. -3, 6, -1/2, -12, and positive 24. How do I get the next number? What am I doing here? Yes? You are multiplying by -2. Is everybody with me on this? Okay, I'm not adding the same number each time. That wouldn't work. Multiplying by a -2. And I can get that if I take 6 and divide by -3. What is that? -2, right? What about -12? And divide it by 6. What is that? -2. What about 24? And divide it by -12. -2. Okay, so you have these three skills here. examples, all to prove to us that the common ratio is what value? What is it? Can't hear you. -2. And what is the very first term? What is the very first term? -3. Okay. So those are our first examples. All right, we've got a couple more, and then move on to the next lesson. Okay, so this little code here is no good. This for us in this class, it's Unit 5. Find given term. It's Unit 5. I'm not sure which skill it is. I don't care right now. We'll worry about that later. But you are going to find a given term when a given arithmetic when given an arithmetic geometric sequence. Okay, so here, there's some sort of sequence. I want you to find the 9th term. Here, there's some sort of sequence. I want you to find the 8th term. I'm not going to tell you exactly how. I think it should be relatively obvious, but I want you to give that a shot. So right here on the video, I'm going to pause it and let everybody give it a shot. You come back to me when you're ready to check your work. Okay, so we've taken a few minutes to practice these ourselves. Let's work on them all together and see if we're on the right track. To find the 9th term, I've got some tricks that I like to use. You don't have to use these. You may have some other way of doing it, but pay attention here because maybe you can apply what I use somehow. In my head, this is what I do. I don't normally put this on paper, but I do this in my head. So this is the first. Oops, let me try that again. This is the first term, 2nd term, the 3rd term, the 4th term, the 5th term, and I want to go to the 9th term. So I got to go 6, 7, 8, 9, right? 6th term, 7th term, 8th term, 9th term. Now, in my head, I almost produced this little chart, this little table. It helps me to not get lost. Okay? Now, by the way, this is the value of n, and this is the a subscript n row here. All right? So, if I want the 9th term, what I have to do is just figure out what am I adding or multiplying by to get the next term in this case. And so in this case, I can see that I'm adding what? 2 each time. So I'm adding 2. So I'm going to add 2, add 2, add 2, and add 2. I'm going to add 2 4 times. So I've got 13 plus 2 is 15, plus 2 is 17, plus 2 is 19, plus 2 is 21, and there is my answer, 21. Got it? Next problem. If we're going to find the 8th term, I realize I got 1, 2, 3, 4, 5 terms shown. I could divide it again up like I do. Let's see. So there's 5, 6, 7, 8. 6, 7, 8. Now, this is n. This is the nth term. So what is the pattern here? What am I adding or multiplying by each time?
3.
Multiply by 3, right? So I got to multiply by 3 times 3 times 3 and times 3. Got it? So 81 times 3. I'm gonna ask you to help me out here. I think this is what, 243? And 243 times 3 is? Say again?
I said something.
Something. 729. And what's 729 times 3? 2,187. That's correct. Okay, 2,187. Down here, 10th term. I got 1, 2, 3, 4, 5. I got to go 5 more times. What is the pattern here? Multiplying by 2. 1, 2, 3, 4, 5. Okay? So this is 6th, 7th, 8th, 9th, 10th. Okay, so what am I doing to get these terms? I'm multiplying by 2. So I'm going to multiply by 2 times 2 times 2 times 2 times 2. So that is 32 times 2 times 2 times 2 times 2 times 2. So 32 times 2 is 64, times 2 is 128, times 2 is 256, times 2 is 512, times 2 is 1024. Is that what you got? Okay, so 1024. Are you with me? We doing good so far? All right, so find the 12th term. So I've got the first 5 terms, and I want to go to the 12th term. So that's 6, 7, 8, 9, 10, 11, 12. 6, 7, 8, 9, 10, 11, 12. Okay, so what is the pattern? What do I have to do to go from 7 to 10, 10 to 13, and so forth? What am I doing? I'm adding 3. Now, let me stop you right here. Let me stop you right here. Is there anybody here that gets a little bit annoyed at, you got to take your calculator, type in 19, and then type plus 3, plus 3, plus 3, plus 3. Raise your hand if that annoys you after a little while. It's like it's okay if it's 1 or 2, but if you got to do it 7 times, it kind of stinks. Yeah? Okay. You're right. You can hit plus 3, enter, 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 you know, whatever, plus 3. But still, you've got to press a bunch of times, and you have to count. You've got to keep track. And that's the problem. For me, it's the problem for me to keep track. It's the problem for you to keep track too, right? But honestly, though, because if you're off, if you press plus 3 just one extra time, then you miss the problem. You miss it. Or if you don't press it enough times, if you're just one off, you got the answer wrong. Okay? So, what I propose is a shortcut. What is it that we have to add each time here? We have to add 3, yes? So we're going to add 3. How many times total do we need to add 3 to 19? What'd you say? 7, right? So plus 3, it's 1, 2, 3, 4, 5, 6, 7. So I'm going to add 3 7 times. That's the very definition of multiplication. Repeated addition. Plus 3, plus 3, plus 3, plus 3, plus 3. That's just plus 3 times 7. So type in your calculator 19 plus 3 times 7. Do it now. 19 plus 3 times 7. So it's 19 plus 21, which is going to be 40, right? So that's going to save you some time. You with me? Alright, so I want you to do these 2 problems, this one and this one. If you haven't already done them, you need to do them for homework. I'm not going to go over them right now. We've got other stuff that we got to do. So that's part of your homework, and we're going to keep going. Okay, so I'm going to actually stop this recording here, stop this lesson, and then we're going to move into an extension of this lesson. All right, so if you've been watching on the video, thank you very much, and check out part 2.